Okay. Welcome to the an extra session of NPTEL C programming. And here we are mainly concerned about learning C programming and trying to use C for solving different problems. And this is not related to any particular week's thing. This is an extra session which we are organizing just to tell you some stuffs which are not generally covered in the entire course. This is mainly sort of you can think of a little more advanced than what's typically covered in the course. And we are going to cover here things related to dynamic memory allocation, and also there are different aspects of pointers like function pointers specifically, which we will be talking about. And then we will be talking about file IO in C, and then we will be using this all together in one kind of an example project. Will be using different of the things, which first we will be discussing it separately, and then we will be using it together as an example. And that's how I think this course will go. And it is also like one of the places where you can ask any questions or any doubts which you might be having, as this is like the penultimate session. So any doubt or any questions which you have had for a long time and you wanted to ask, then this is also the right time when you can clarify those doubts. And then we will be having the final session on coming Saturday. So this is mainly the idea of today's extra session. So let us get started, and I'll be just going through some of the things which we have already covered, but in a slightly different way, or covering some advanced concepts which are typically not asked in this course or typically not covered in this course. Uh, so this is just a way for you to look forward from here what you want to do, and if you are wanting to use C for any kind of work in your future, this is kind of the thing which makes you somewhat ready for that. Okay, so let me start by sharing my screen. I hope my screen is visible. Just let me know once, and then I can start the session. Okay, great. So as we have already seen these, there are these hello world. This is kind of the most simplest hello world code in C, which is I am using VS Code for it, but you can use any kind of code editor for doing this. VS Code is just an example of an IDE, which is very simple to use. And now what we will be doing in here is first, as you remember, last time we covered different numerical algorithms for solving integrals. So we will be using a similar trapezoidal rule for solving an integral, but it is will be a kind of something which is different. So, but before that, there were also a concept of, I guess, if I remember correctly, static variables which were covered. So I wanted to also give you an example of how these variables are dealt with in C language. So let's first create like a sample function. So it's a very simple function. So we just create int so test. So this is a test function which is going to doesn't take anything to say. And inside the body of the test function, let's create some variable. Say int x equals to 0, right? And let's say this function gives. So as you know that this int is telling you what is the data type of the thing that is returned by this function. So if I do something like an int star, what this would mean is that this function is going to return a pointer, right? So if I do int x0, and now if I do a return int and x, okay? So now what this is doing is it's just returning the value, the address of x. And means, as you remember, if you remember correctly, it means address of. So it returns the address of the integer variable x. So this is kind of the function. And now what I want to do in here is just create like create an integer pointer, and I call test. And here I just want to print the value, and also, yeah, I just want to print the value. And let's also say I want to print the address of as well. Print f, oops, here, and let's do something like, yes. So this just prints the address of the x, and then the value of x equals to. So now what I'm doing in here is first I'm printing the address of x, and then I'm printing the value of x, right? And let's have it like this so that it just starts at the same place. And this is how this would be. Okay, so now let's instead of zeros, let's have something like 5. So now what you'd expect in here, naively speaking, is that the address of this variable x will be printed and the value of this variable x gets printed. So let's see if I try to run this code, what will happen. This is some, you will perhaps not get something which you expect. And you see that here is the thing problem. There's a warning that the address of the local variable and x, and here you see that the address of x is 0, and after this the function just stops, right? And the reason that this happens, that your code is stopping in here, let's see, yeah, is because there is a problem, as you can see here, which says that this integer variable x, and you see the value of x is not coming up as 5. You see that the value of x is coming up differently. And the reason for this is happening is because every time you go to a function, happens is that any local variable, so this is something called related to scope of the function. And if you see that this is a local variable, and as soon as you come out of that function, these local variables are destroyed. So any value which was in this local variable got destroyed, and therefore when you are outside this, you see that the value of x is not remaining proper, right? Because the value of this is getting destroyed. Just to show you that this is exactly what's happening, what we can also do is create another variable, say um, b, let's call it b equals to 10. So this is like another variable which we are creating. And similarly, let's also do something like print f address of, first let's print the value of b, and let's just print the address of b, right? So now you'll see that for this one, things will work fine. And this is because you know that, yes, here you see that the value of b is 10 and the address of b is fine. But for x, it's not working. And the reason for this, as I was saying you, that it is a local variable, and this local variable is getting destroyed as soon as you go out. So the way to get around this, that if you want to still have some local variable, and whenever you come back, you do not want the value of x to get destroyed. You want x to hold the previous value of what it was. And for this, what people use is a static variable. So you use this keyword static, and then you return the value of x. And let's see then what happens when you do this. And you see that now here, the value of x is 5. So the value of x is now holds on to whatever it was, and it is not destroyed. So the concept of a static variable in a function is that whenever you have a static variable, and though the value of corresponding to that static variable is retained after the function has executed. But in case of all the other variables which are not static, the value of the function is not retained. And what happens is that the value gets reset. And so you will not be able to access the value after you have come out of the function. So any local variable which are static, its value is retained after the block. So this is kind of the block where you have this braces. So the block has you have come out of the block. So this is kind of the idea. So if you have any doubt at this point regarding what we were discussing, please ask it in here. Otherwise, I'll just move on to something called this dynamic array. Yes, if x is declared globally, then obviously there is no problem, because the scope of the variable is larger. So this is only happens when the scope of the variable is small. So if you have a local variable, then and you want to use the value of that variable there, or when you come back to the same function, you want to use the same value. In those cases, you want the thing to be static. Otherwise, it will not hold on to the value once you come out of that particular scope. And if it is globally, obviously the scope is there, and the function will and then retain the value. Yes, then the function will retain the value of 5, and then it will not be reset once you come out of it. So the idea is whenever you come out of the scope of any particular braces, so each of the scope, like each of the opening and closing braces are the scopes. And whenever you come out of the scope, any variable which are not static declared inside the scope gets completely destroyed. in terms of the what are the values they are having. So, and if you do not want anything to be destroyed, then you want the scope of the variable to be much larger. So this is kind of the idea, and therefore you use the static variable. So whenever you return back, it holds on to whatever it is. Yes, the lifetime of X is then like it's retained, it's forever unless your program stops. So the value of X, whatever it was before when the function executed, is kind of retained. And that's why when even after the function is executed in that same memory location, the value of 5 is still retained and not reset. So the same regions are retained in that sense. So I hope this is clear. And yeah, and then I can move on to show you something about dynamic variables. Okay. So now let's move on, and let me tell you about something called a dynamic array allocation. So what's happening in here is whenever you create an array, not only just array, any variables in C, normally speaking, all these variables, the memory in all these variables are put on something called stack, which is a smaller space. And whenever the variables are put on stack, you have to know from beforehand what will be the size of the variable. For example, when you are creating a variable int, for example, here, int b equals to 10, then you know for sure that this is an integer, so this will be a 4 bytes, right? Similarly, like if you create a char, for example, if you create something like a char ch equals something like b, right? Then you are sure that this is a 1 byte thing. And any variables that you create in C where the size of it is predetermined, you know from the beginning what's the size of it, those are generally allocated in the stack. For example, even if you create arrays, so int a, say 100, then you already know that this is an array of of integers having 100 elements. So it's, if each integer is 4 bytes, then this is an array of size 400 bytes. So you need a region of 400 bytes in the memory, and that region is kind of allocated in the stack. But when you have something where the value of an array or the size of an array is not known from beforehand, then you what is called dynamic array allocation. Or what this means is that the size of the array or the amount of memory required for you to create that array is determined during runtime, is determined when your code is running. So, suppose, say, you take first a value n from the user, which tells you how many number of elements you want in the array, and then you populate the elements of the array from the user. And in that case, it's a dynamic thing. So you do not know from beforehand what's the size, and you have to set the size from the user. Or similarly, you say you have a file, and from that file you want to read in the number of lines. So you do not know beforehand how many number of lines do you need. So if you want to create an array of all the, which would have the entries of all the lines in a file, then you would have to again do a dynamic array allocation. And these arrays are not used on stack, but these arrays are allocated on heap. And the idea of heap is that the size of arrays can be much larger compared to stack. But the downside is that the heaps are a little bit slow in terms of memory input output, like in terms of memory read and writes. Heaps are a little bit slow compared to stack, but it allows you to have very large amount of storage, and like storing very large arrays in memory in the RAM itself. And therefore this allows you much more flexibility to, as far as I know, that stack stays in the registers in kind of the resides in your CPU. That, like, there are small memories in the CPU where it lies. Whereas if you think about the heap, it is using a large chunk of space from your RAM in the computer. So depending upon your size of the RAM, you can have very large arrays which you can manipulate and deal with. And also, one thing to be very cautious about using dynamic array allocation and using the stack, especially in the context of C programming language, that you are responsible for freeing the memory. So what I mean by this is that, as you were seeing here, the static, I have a variable x, and if this variable is not static, then at the end of all this run, the variable is reset. Therefore, when you are by resetting the variable, what it means is that the memory which was occupied by x can now be used for any other purposes, right? So you can again reuse that memory which you were using for x, and this C does automatically. You do not have to care for it. But whenever you create new variables which are using this dynamic array allocation, then you are responsible for freeing that memory. And since, as I was saying, that generally people use the such heap memory for very large storages, and you can imagine that, say you are doing a for loop, and in every for loop you are creating new and new arrays, right? And so you are assigning more and more memory. And if you do not, at the end of the for loop, if you do not free the arrays, then those parts of memory are already occupied. And it can happen that your program can either run slow or completely crash, because you have not freed the memory and there is no memory then left in your RAM. So it's up to you to make sure that whenever you are done with that particular variable or with that particular array, you free that memory so that the same memory can be then used by other parts of the program. And this is an important thing that you should keep in mind. If you do not do that, there is something called memory leak or segmentation faults that happen in your program. And this is a very common mistake done by many people, including myself as well, and many times while writing C codes. And this is something you need to keep in mind. Yes, these elements can be anything. Even if this can also be structures as well. It can be structs, it can be float, it can be anything. So we will be actually using some dynamic memory allocation with floats as an example here. Okay, so let's start. So how this works is, first we need to create a pointer, which will be the array. So let's call this float star p, right? And let's leave this for now because we don't need it. And here, what I'm going to do is I am now going to say create an array, right? So float star, sorry, star. So let's first tell you what. So if you do something like this, this is that's a static memory allocation. So you know from beforehand your array is 5, and these are the 5 elements. So this is done on the kind of on the stack and not on the heap. And this we have already dealt with. So we will not do this. Instead, what we will be doing is something called, as I was saying, dynamic memory allocation. And what for that, what we will be doing is something like this. And then we are creating a new variable. And for that, you do something like a float star, and then you do a malloc. Okay. So I'm now going to explain what this command really means. So what this means is that malloc, this is a standard C function called malloc, and this stands for memory allocation. So this allocates memory. How much memory do you need? And now I want to create an array of size 10. So say, let me do that. So let's say int n equals to 10. For now, this size is fixed, but you can think about n being taken from an user. So just for the sake of simplicity, now I'm just taking n, defining the n to be fixed to 10, but this n can be taken from the user. So then n is determined at runtime and not compile time. But for now, in this specific example, to begin with, I am having n, which is fixed to this value of 10. But later on, we will be taking it from the user. And in that case, the n will be defined only when your programming is running and not beforehand when you are compiling the code. Okay. So now you start with this, and you have something called float star ARR. So this creates your pointer to float. So this, all this says is that you create ARR, which is a pointer of type float. And malloc, what malloc is doing is doing a memory allocation. And what I want is I want malloc to allocate. Now you give how many bytes, how much bytes do you need, right? Which malloc gives you. So now what I want is the size of float. This is again a key word in C. So this gives you the size of any particular data type. So if you give size of and if you give float, then it means that what is the size of float. For example, in case of float, we know that the size is 4 bytes. So what this is doing is telling me that telling the compiler to just in the heap allocate an amount of memory or block an amount of memory, which will be of 10 times the size of float. So then this will be, therefore we have enough memory to put in 10 floating point numbers. So that's the idea. And after all of this, this float star, this is a typecasting. What malloc does, it first creates like a space in the heap corresponding to whatever you pass. So this is the amount of space that gets reserved, and then it returns a pointer to from which points to the beginning of the stack. So you can think of this as a continuous memory region. So let me open up Paint for you to just to demonstrate what I wanted to do. Okay, so imagine that this is your memory. And when you do a malloc, what this would do is that this will reserve this portion. This is some region in the memory. This is what it's reserved. So this is like you have like size of float, which is 4 times n, so which is 10 for this specific case. So like 40 bytes has already been reserved. And now what it does, it returns a memory address which points to the beginning of this space. So this is ADD. If I tell this is address, this address is what is returned. And the type of this address is by default void star. So this is this corresponds to void star. But we know that what we want is not a void star but a float star, because this region should contain an array of type float, and that's why we need to convert void star to float star. So malloc by default gives in void star, but we need to convert that to float star so that all the floating point operations and everything moves by 4 bytes and not just 1 byte. So if you have a void star, it will move by 1 byte, and we do not want that. So that's for that reason we convert it to float star so that the pointer arithmetic gets proper, and then we assign it to ARR. Okay, so this is exactly what is happening in malloc. So this is one of the most important kind of commands in dynamic memory allocation on the heap. So make sure that you understand this. And I will pause here for a while if any of you have any questions at this point. Declared int value to be 10. Yes, exactly. The declared int value to be 10 and allocating with float size bytes. Yeah, exactly. So that's why we have this n star size of float. So what this means is that each element is of float size, and we have n such elements, right? So if this is int, if you want to create a variable of integers, then you replace the float with ints. Okay. So now once this is done, we can have a print statement. So we can have something like ARRI, and then we can do a print of that array, right? And this is what generally happens. And let's now just print this code, like run this code. Let's just for the sake of the display, so that this becomes display small, we will make it 5 so that we can just fit in here in this small screen. And let's just run it. And you can see that these are floating point numbers, and that is starts from 0, and I just have the values assigned. So 0, 1, 2, 3, 4. So all these 4 numbers. Now what I'm going to do is, now I'm going to change the number of values that I put in, and then the array will be of like that. So then this becomes, shows you the true power of dynamic array allocation, because it allows you to have the size of the array determined during runtime. So let's do that then. So I'll have just int, and then I do a printf, enter the number of elements, and here then I scanf. So I just take the print now from the user. So now the code doesn't know what will be the size of it until the code runs. During the compile time, it doesn't know, but still everything works fine, and the array gets created according to whatever the user gives the size to be. And now let's run the code. And let's now give it, say, a value of 3. Hit enter, and you can see you have 0, 1, 2. So that's the array which is now getting formed. So this is how this dynamic memory allocation works. And now imagine, and now there is one thing which we have missed. And for this specific case, this is not a problem. But this code, if you run this code again and again in a for loop, like have lots of mallocs, if you just have many of these mallocs in a for loop, then there will be a problem in this code, because every time you call a malloc, a fixed region of the array of your of the memory gets assigned, and this is not freed when you come out. So it is your duty to free whenever you create some kind of an malloc. So always keep in mind that whenever you have a malloc, it should come with a free statement. Otherwise, this is a memory leaking code. For example, this code, although runs perfectly fine, has memory leaks. And this memory leaks can be disastrous when you are running a very large code with a lot of large sized array. And then you can quickly run out of memory in your processor, in your computer, and then your computer can either crash, or your program can crash, or you can have segmentation faults, which is very bad. So what you need to do is, after you have done everything, you just call free, and you just pass the array, so ARR. So once you do call free, what will happen is that the memory which was assigned, so this part becomes free. So this can then again be reused by other codes, or your same code at a different point of time. So unless you free the memory, this always remains reserved. And imagine that now you have multiple mallocs going in a for loop, so you are continuously reserving more and more space, and unless at some point you will be running out of space, and then you will have memory leaks. And this is not good for the program, so as to speak. So it is your duty that whenever you are using a malloc, always have a free statement. Okay, so now this runs fine. Now if you this will always run fine, in the sense that this is a very small code, but when you can have very large arrays, then these memory leaks can be a substantial issue. So keep this in mind. Yes, this is the deallocation thing which I was talking about, this free thing. Whenever you give free, this deallocates it, and so you will not have things which is reserved. I hope this is clear. Okay, okay, great. Right. So this is kind of the basics of dynamic memory allocation. And now I will be going to file IO and and show you how you can use C programming language to write to a particular file, or read data from a particular file. And then we will be using and we will also be using the concepts of dynamic memory allocation here as well. So let's do that. Like different aspects of file IO. And this is particularly useful when you have large data which you want to read from a particular file. And this can be like two columns of data. For example, you can have like a text file. In the text file, you will have like two columns of data. Like this can be X values, and this can be Y values of anything. For example, you are doing an experiment where at every time you are noting the velocity of a car, right? So you say that initially the velocity is 0. After like 5 seconds, its velocity is 10 kilometers per hour. And then after 6 seconds, after like 10 seconds, its velocity is 20 kilometers per hour, something like this, right? So you're just having an experiment where you are dumping the values, and then you want to have a C code which can read this and then do whatever processing that you want. So something like this. This is just an example of reading files. So file reading is quite important, and this reading of files is needed when you have a file. For this specific example, I'm assuming a text file, and now this text file is what we are reading in and putting in the values. Now, as you can also imagine here, unless you read the file during runtime, during the compilation of the code, you do not know what will be the number of lines. So then you do not know what will be the size of your array, right? So this is again a place where you need to use dynamic memory allocation, and this is precisely what we will be using as well. So now let's get rid of these parts of the code, and let's call it, instead of ARR, let me call it X, and I'll have a free X, right? And let's now do a file IO. So let's have n lines, right? And first, let's create a file. So first, I'll show you how to create a file, and then we will read the file, okay? So for now, then, let me comment this out, because let me just remove this because we don't need. And let me just create n lines is equals to, uh, let's not even have n lines. We will put in from the user itself, right? So, okay. So let's have a file. So for using file, you have to use something called a file pointer, and which works like this. So let's have a fp equals to fopen demo.txt. So now what this would mean is that I want to open a file which whose name is demo.txt. I want to create this file, and W means write. So there are two modes, specifically W means write mode and R means read mode for reading the file, and W is for writing the file. So I want to create a file for writing. So I just call it, and this is the file pointer, FP, which I am using. So now let's take and use something like this. So what this would mean is that if fp equals to null, then error in opening the file. So this is like a safety statement. You always must have something like this. When fp equals to null, this would mean that this is an error. So after this line has run, you must have a value to this pointer which is not null. And if you have a null, then you must be having some error. For example, it can happen that the place where your program is running in the hard disk, there is no space left in the hard disk. Then what will happen is that it will not be able to create this file, and then you will have something like a null. So this is like a safety check which you must which is recommended. It's not compulsory for you to give, but it's recommended that you give this. And if p equals to null would mean that you are not able to open that file. So this is an error that can happen. Okay. So provided that this error has not happened, we are now going to take some data from the user and put that straight away into the file. So let's just do a printf, enter data x, y. Okay. And we'll have something like this. Right. So these are just going to enter the data from the user, and we will have something like an int xy, and then we are just scanning the f. So this just scans the values. So instead of int, let's have something like a float, right? And let's have something like percentage %f. So we will take in some floating point numbers from the user, right? And then we will be using this. So just like printf, if you do an f printf, what this does is it just kind of puts in the values which we want to put in, right? And one more thing which we can do is that we will do it again and again in a while loop. So that's why I give something like a while one, and let's not have this scanf in here, but scanf in here. And at the end, this is again just like we had a free thing. I'll come to what this while loop does, but one thing I want to tell in here that just like we had something called free because of a dynamic memory allocation, whenever you create a file pointer, this is like a file pointer for writing or reading file, you must always end with f close. So what this does is this closes your file after every operation has been done. If you do not do this, your code can work, but sometimes what can happen is that your file can get corrupted. So it's highly recommended that you also give an f close, fp, which ensures that you do not have any corruption of your file after you have done with everything. Okay. So now what this while loop is doing is that I'm taking in two values, and whenever I give, and I will keep on doing this, like I keep on taking x and y values until the user gives -1, -1. Then I'll know that, okay, I am at the end of taking in the reading. Imagine that this is kind of the reading that you are taking in, like the velocity of the car at different points of time. So you are just putting in t and v, t and v, t and v. And after a while, you finish taking your reading. So you just give -1, -1, and then you break out of the loop. And every time you give a reading, it is getting stored in the file, which is something like demo.txt. So let's just call it data.txt. Okay. And so this is kind of the basic program, how it's running. So let's just try to run this and see if this is running properly or not. Yes, it's running properly. So it asks for the data. So let's just put in some data. For example, at 0, say the car velocity is also 0 at time t equals to 0. And let's just say at time t equals to 1, the velocity of the car is also 1. And at 2, it kind of squares itself. Say this is just a simple example. It can be anything. I'm just making something up on my mind. So now you have something 2, 4, and then you have something like a 3, 9. So I'm just squaring the thing. And then now if it's at 4, then it will be at 16, and then it's at 5. So it's at 25, something like this. And now say the car has, I've finished my experiment. So I just give a -1, -1, and hit enter. So as soon as I give minus one, the program comes out of this while loop, and then there is a f close, so it then closes the file and gets out of it. And you can see there is a data.txt which got generated. And if I open it, you see that exactly the values which I have put in 0, 0, 1, 1. So all these values have now come in here. And this is how a basic file write works in C. I hope this has been clear to you. So let's pause for a while. And if you have any questions right now, please feel free to ask. So you can open actually many files together. Again, depends on your memory in the RAM. So if you can accommodate like any a file which is large enough, and then you can also have lots of file open. But it is your duty to always have an F close at the end of it. Unless you do that, sometimes it can happen. It will not. It is not guaranteed that every time it will happen, but sometimes your file can get corrupted. So make sure that you have an F close at the end before your program ends. Yeah. Okay, sure, sure. Absolutely. Real-time data can be large. Okay. So now that we have already talked about kind of reading a file, now, writing a file. Now we will be reading this file and just printing the values that we have read in. And as you can understand, the size of the file is dynamically allocated. So we will need a dynamic arrow, like a dynamic read-write thing. So for that, I'll just create a new C file and just have something like a hello world to start with. Okay, this is the basic hello world thing. And now we will have something like a dynamic memory reading. Okay, so let's do something like int star x. Sorry, we are using floats. So we have something like a float star x. And so this will be x and y values which we were reading in. So something like this. And then we have something like an int. So this is int n. Lines. So these are the lines in my code, which I obviously don't know what it is. And so far, we have to know what are the line, how many lines there are. So we'll start with n lines equals to 0, and we will keep on adding one more line depending upon how many lines there are in my code. But now, so now for now, I'll have to have a file. So I do a file star, and instead of input, this is called data. So I'll just take in data.txt. So the way this works in the naming is that it is with respect to the current folder. So wherever the directory is, since I'm right in the same directory, I have like you see that I'm in this directory and I want to access data. That's why I give data.txt. But say if I'm in a subfolder inside data, for example, I have a subfolder called extras, and if my file is in extras, then I would give something like extras slash data.txt. So it depends on so whatever you give in here is a relative location with respect to the where your current file is or your current executable is. So this is the relative location that you have to give. So this is also something to keep in mind, that the location that you give is the relative location. So since my code is at the same position as the data, I just give data.txt, but for you it can be anything depending upon your context. Okay, so I am reading it in. So make sure, since I can forget at any time, so it's a good idea that I also give an f close right away. I just call it fp because it's a file pointer, right? And now I'll do whatever in between, right? And now I'm just going to read in the values. So for that, I am just going to read in a while loop. So I'm just now going to read like the numbers in here, and let's do something like I can do something like I will count the number of slash n's, and from there I can understand how many of it is kind of how many lines do I have, right? So for that, I will do something like So I'll just go to extras and show you something which I had already had done. So this will just be better in terms of understanding. So this is the kind of the code which I was looking for. So I'll just explain what this does, and then we can uh, talk more on this. Okay, so let's not go in here, but I'll and okay, let's explain what this does. So you see this F, so these are like different standard C functions. F get C and FEOF. FEOF stands for end of file. And like these are the different standard functions. And let me just save this code. Here, let's call this read.c and save this. Okay, so I have this read.c created. And let's now look at this. And I call this not file, but FP this as well as FP. Okay, let's see what this does. So what I'm doing in here in line number 5 is I'm creating this pointer with data.txt and r. So this is reading the thing. And now I have something like n lines equals to 0. So I start with 0. And while not equals to EOF FP. So what this means is that at the end of like if you are at the end of everything, then what you are going to have is something like, okay. So now what if you are at the end of it, then what you will have is FEOF. So EOF means file end of file. So FEOF means, so when you are going after you are reading characters, and then what I'm doing is this F get C. What is F get C is doing is reading characters one at a time. So you read something like this. So for example, if you look at the file that we are already having, let me open that data. Okay, so what I'm doing in here, I'm reading 0, then point, then 0, then I'm just reading one of the characters at a time, one by one, right? And I keep on doing this unless I get to the end of it. So once I go to the end of it, what I'll have is FEOF. And this so this while loop, what this while loop does is it will keep on reading unless the FEOF is true. So not FEOF means when FEOF is true, then only I go out of that while loop. And if I'm not at end of file, then I am inside the while loop. And now char ch is just reading the character and this get C. So I'll use the debugger in here just to show you the flow of the code of how this is happening. But this is the idea that I'm reading each and every character. And as soon as I'm getting a /n, so /n means the new line. So every time you reach the end, there is a /n in here. So you go to the new line, and then again you go to the new line. So every time I hit a /n, I have a something like a n plus plus, right? So let's go file read. So I have an n lines plus plus. So n lines increasing by 1. So at the end of it, I have counted the number of lines in my file, and n lines equals to 0. So at the end of it, if n lines equals to 0, then I'll know that there is no data in the file. So that's an error because the file is then empty. Otherwise, I'll just say that okay, there is no data. This is kind of the idea that's happening in here. And let's not worry about this part of the code right now. Okay, so file read.c. And we will come to this part later. So let me remove this. Where am I? Read.c. Sorry. Okay. And let's not worry about this part of the code. Okay, so this is kind of the thing. And now let's try to run this. And then I also explain what this reverse means. But for now, let's just run this code. Okay. So there seems to be some error which has happened. So let's see. Let's try to run this. Let's not have this anymore. end of the file. This is n lines, and this is end. Save. Okay, I think I have encountered some errors. So let me close VS Code for now and just open VS Code once again in case there has been some errors. Okay, let's see. I'm reading in the files here, and then I go till the end. Let's see. No, still errors in here. So let me see what I did in my test code, which I was preparing before the class, just to see if there are some. Okay. Okay, I think now this is running fine. So let's just come to here, and I'll open the debugger for you. So something had gone wrong with my previous VS Code thing, because now as I see, I have restarted VS Code, and now this seems to be running fine. So I create this file star p, and after that I create this data, and I have something like a null. So this, as I was saying, this first says that whether I can access the file or not, and indeed I have something like data.txt, so I can access it with a read permission. And then I go to n lines equals to 0, and now I go through every elements in the line, and I see whether there is an element where there is a slash n or not. I count the number of new lines, and accordingly I increase my n lines, and then if my n lines is 0, then I just print 0, and otherwise I'm at the end of the file. So before closing the file, let me give a print statement just to print the number of lines and make sure that what we are getting is right or wrong. So the number of lines is 6, and if I open data txt, which we have created, and you can see obviously there are 6 lines in here, and 7th line is just blank. So there are 6 new lines. So I think this is working fine in terms of what we are reading. And now let's also give a debug statement in here and try to debug the code, just to be clear that what this while loop is doing. Okay, so let's do that. So we are in the debug terminal. Here you can see, and let's look at the local variables. As you can see, we are starting in here, and we are at in this file thing. So this is the memory location of where the file is. So this is 0x00fp. This is kind of the memory location where we have read in the file. And now we are going to the next step. And you can see the first line, which is read, is 0, because as you can see in data, the first is 0. So that's what is being read in here. So we will step through. And this is obviously not equals to slash n, because we are not at a new line. So we go back, come back to the while loop, then read the next thing, which is again point. So you can see now ch has changed to point, because now this is point, which is what we have read. Come in and check this is not equals slash n, and then again keep on reading this. So we keep reading 0, right? And 0. So we'll do this like a few zeros in there, because the data, as you can see, there are a lot of zeros which we are reading in here. So let's go through the while loop one by one. And now you see we have read in space. And after that, we will now again read in a 0. As you can see, now this has changed to 0. This is now the next y value which we are reading, and then you see that we have a point. So, and as you can see, also n lines is still 0 because we are still in the first line. So now we are also again reading in a few zeros. Let's keep on doing this until we hit to the end of the line where instead of a 0, we will have a new line. Yes, now you see we are at new line, so it's slash n. So now you see we are at a new line. So now this is satisfied. So because at the end, we are at the end of it. So we have read in all the zeros in here. And now we are at a new line. So that's what we are now. And now ch equals to slash n, we are going in. And now n lines is plus plus. So now n lines is increasing by 1, as you can see in here. Again, we are going in. And now we are going to the next line. So now we are at next line. And you can see in the next line, we have 1. So that's the first element here is 1. So if you just do a step like this, you see it has changed to 1. As you can see in here, this ch has changed to 1. And we'll again go, and then it will change to a point right now. As you can see, this has changed to a point. So this now logic keeps on going unless we hit the end of it. And let's do that. And just we continue to run till the breakpoint. And get rid of this breakpoint, and now you see we n lines is 6 because we have called through the code and calculated the number of new lines. And if n lines is 0, which it is not, then it will say that there is no data in the file because there are no lines in that case. Otherwise, like it is just comes in here and it tells you that, okay, the number of lines is this much. So you have 6 lines in here. So this is kind of the basic idea of calculating the number of lines in the file. So once we have calculated the number of lines, then we can now do a dynamic memory allocation to create the array. So this is exactly what we are now going to do. So let's stop the debugging for now, and let's go on to create dynamic memory allocation. But for now, I'll just pause for a while to ask you if there are any questions right now at this point. So the main idea for showing this was to also show you that these different commands which exist in case of dealing with files like fopen, feof, getc, fgetc, and fprintf, which we have already done in writing case where we write data to the file, we use the fprintf. Similarly, these are standard codes which feof, fgetc, something like this. So make sure that you understand, then only I'm now going to move on to the next part. Okay, great. Thanks for confirming. So then we will just now, as I was saying, that move on to we'll just get rid of this and create read in the number of lines. So we'll create user malloc. So we have something like an x data for doing n lines, and then we will have something like y data, which is now going to be a malloc again. And then we obviously want to free this. So we'll have a free x data, y data. So I always, as soon as I create malloc, I always do this because this helps me then go and right. So this then helps me remember that I have freed it. Otherwise, I just forget. So every time I do a malloc, I always give a free at that point of time and then put in all the code in between. And now I need a rewind. So what rewind would do is that put my, as I was saying that as I'm reading through the file, the place where I'm reading is updating by every place. So my pointer where I'm reading it. So you can think of this as the cursor. The cursor is moving, and as I'm reading through. So since I've found out the number of lines, my cursor has moved till the end of it. So now if I go a rewind, what it will do is it might place the cursor again to the beginning, because now I'm going to go to the beginning and then reading the data now, the individual data. So that's why I give a rewind statement. This is also like a standard C function which I'm using, and this now goes to the beginning of it. And now I'm able to I'll be able to now read in the individual data points right now, because my cursor has now again moved to the beginning. So that's why I have this rewind file. Okay. So now I do a for like a for loop in here. So let's do that. Okay. So now just like we have a printf and scanf. Printf is for printing to the screen, and scanf is for scanning from the user, that the user gives the data from in the screen. Similarly, we have fscanf and fprintf. Fprintf is writing to a file, and fscanf is reading from a file. So now we are going to reading from the file. We give the pass the file pointer, and what we are reading is our float. So we have this percentage f, and then what we are reading is x data I and y data I. So whatever we are reading in, we just gets passed into X data and Y data. So that is exactly what's happening in here. And after this, just to ensure that we have gotten the right thing, I do this where I just print. Then I go to the number of lines and I just print the X and Y which I have read in, just to give you a hint of what we are doing, right? So this is the thing. And now let's play this code. And you'll see that this entire thing, what was there in terms of stop. I don't want to debug the code. Instead, I want to run it. So let's run the code. And you see whatever gets printed to the screen are the same data points which I have put in the beginning. So you see that I have put in something like this. So I have read in those data points which were in data. So 1, 1, 2, 4, 3, 9. So this is what, so I start from 0 actually. So 0, 0. So this is the first data, and then 1, 1, 2, 4, 3, 9, 4, 16, and 525. So now I have read in the data. So what this code entirely does is, first it opens the file. After opening the file, it counts the number of lines. Depending on the number of lines, it dynamically allocates your two arrays depending on the number of size. So size depends on the number of lines, and these data is allocated on the heap in here. After doing that, it now reads the file and puts in the data which it is reading from the file to this X data and Y data arrays. After it has done that, it is printing the values. And after all the print and everything is done, it closes the file, and then it frees the memory which was used by these arrays. So this is kind of the scenario which demonstrates the entire procedure of file I/O, reading data from the hard disk and now processing the data into files. And this data can be anything. For now, you can think of this as this toy experiment, which I was saying, that every point of time you mark the speed of a car, right? So this is the idea. So I hope that this is clear to you. If not, you can please interrupt me anytime you wish to ask questions. Okay. So I am now going to move on in here to the next part, where we are now going to process the data. And for this, I am going to introduce something called, say, file pointers, function pointers. And this is also one of the advanced concepts in C. And I'm going to show you how this is quite important in this specific case. So I'm now again going to create one more new file in here. Let's create that. And I'm going to call this just hello. Let's start again with the hello world code. And once I have the hello world code, I'll just have this saved as, say, I call it uh, function pointers, because that's what we are going to talk about right now. So yeah, so this is called something called function pointers of C. So now what is a function pointer? So just like we were talking about it before, that there are pointers to variables, there can be also pointers to functions. So the functions can be addressed as pointers. So whenever you are using that pointer that will refer to some function instead of a variable. So those are called function pointers. So I'm now going to tell you how does that work. Okay, so let me give you an example of how a function pointer would work. And for that, let's just first create a function. Let's say we have a function int, which is, say, I call it func, and say I call it square because it squares your numbers that you give in. And let's not have int, but have float, because we are always dealing with kind of floating point numbers, but it's just an example. You can have anything you wish. And then we have something like this very simple function which just takes in a value and kind of squares it. Okay. And now what I'm going to do is I'm going to create a pointer to this function, right? And that is what is called the a function pointer. So the way you would do this is something like this. Now this is exactly what you call as a pointer function. And this FPTR is the name of that pointer. And and this is a function pointer. So the syntax is this, that imagine, now I'm going to just explain you what this syntax means. So imagine you have something like a float star PTR, right? So what this means is that this is a pointer of type float, right? And why does this mean something like this? Is that here this star happens first. So, but you know that if you want to create a pointer to a function, what you need to do is you need to tell it that, okay, this has to be something like this, has to be put in parentheses so that you have something like a float, okay, and you do an and square. So what this would mean is that and is like square is your function, and square gives you the address to that function. Now, function pointers are, as I was saying, is kind of a something which is quite special in a sense that these are not pointers to any data structures, but these are functions to point us to different parts of your code itself. So this is the part refers to this section of your code and not any particular data. So in that sense, it is quite special as far as function pointers are concerned. And why would one use a function pointer would be clear when I'll be using a function pointer for numerically calculating the integral of a function, like I will be using specifically the trapezoidal integration. But before going to that, I am going to tell you some more features about function pointer. Is that this is the thing where I'm creating. So let's get rid of this line. So in this point, you can see I'm creating the function pointer by using this thing that whenever you give something which is within this parenthesis and then star, then you'll know that it is a function pointer. And everything that comes after it is what are the arguments. That, say, if you have something like a float x and float y, then a pointer which will point to this function would also have something like a float comma float, because those are the data types of this stuff. So since do not have this, so we have something like this, because there is only just one argument which we are passing in, and this float tells you what is the return type of that function, right? And after all of this, I am returning square. So whenever you give the name of the function, it's automatically referred to as and f. So this and this means the same. And this is like a special thing for functions, that whenever you have a function pointer, the name of the function always refers to the memory address. So this and this would work the same way. Okay. And right, because as I was saying, since these are special, so even if you do not give and square and just give square, it automatically refers to the memory address because you have defined this as a function pointer, right? So now what I'm going to do is I'm going to call printf, and I'm now going to call, I'm going to make 5.0, right? And I'm going to like have the square of it. So one thing you can do is, this is like a general thing, square of 5.0. So this just squares your number, right? And you should get something like a 25. So let's first test this, and then we will be using function pointers. So let's just test. This is the normal thing that we have done and that we have also talked about. So, and as you can see in here, the square of 5.0 is 25. So this is pretty standard thing. But the nice thing about function pointers is that since you have a pointer which refers to the same part of the code, so these are like pointers to the part of the code. You can again use the same thing, but instead of square now, what I will be using is fp tr. So this is a function pointer. So this points to a function which is also means the same thing because it points to square, right? And now when I do this, sorry, I think I have done some mistake here. Right. Okay. So I call fpter, and I think I've forgotten beforehand. Let's yes. So CLS, let's clear the screen and let's run this once again. And as you can see in here that oops, run the file. And as I'm running it in here, as you can see, both things are giving me the same thing. So 5.0, I have 25, and the next also it's giving me 25. The way this is working again, as you can see, this is a pointer. So ideally, what you should have done is you could should have given something like a star FPTR. What this would mean is that this is an address. You want to say what is at that address. Star gives you what is the value at that address. But since these are again a special function, so you can use FPTR, and this would mean the same thing as star FPTR. So this means the same thing. So just like you can give and square, it doesn't matter. Similarly, FPTR and star FPTR doesn't matter. And you just can run it right away. And the functions so are automatically referenced and dereferenced. So the idea here is that whenever you have a function pointer, the functions which you are referred to are automatically referenced and dereferenced. So you do not need to have and stars for referencing and dereferencing. That's done automatically. But you can also have this ands and stars, and the program will work just fine. So this is all about function pointers. And make sure that you understand this a relatively difficult concept of function pointers so that I can use it to demonstrate why this is useful when you are writing a large code. Okay, and now if multiple files are open, how you are going to differentiate it? So the way you are going to differentiate it is you create multiple file pointers. So imagine that you have like two files open, then you create something like file star fp1, and then you do something like a file star fp2, right? And now this will be two pointers, and then this will have its two different f opens, and then you need two f closes. So this is how you would do. So you need two different pointers, fp1 and fp2. You can even have an array of file pointers. If you have like 10 files open, you can imagine that you have an array of file pointers, and each of these array will have some kind of a reference to a file, and then you can have an f close which is inside a for loop. So you loop it through and close it. So you can get as much complicated things as you want, right? Identity of the file, that depends on f open, right? If you give an f open and you know whatever you have passed the name in f open, then that would be that file with that particular name is then fixed to that particular file pointer, right? If you like fp1 equals to fopen data1.txt, then fp1 always points to data1, and it deals with everything with respect to data1.txt. Similarly, if you do fp2 equals to data2.txt, fopen data2.txt, then it's kind of tied to data2, and that's how it works. Is that clear? Okay, great, great. So then now let me proceed and tell you how this can become important. So imagine that like just like what we have discussed yesterday about a trapezoidal rule for integration. So we will do a trap Z. And one more interesting thing that you can do with function pointers is that, as you can see, this expression is quite cumbersome. Float this entire thing, which means a function pointer. You can use a type def. So let me do that. So I think what you have already come across type def, something like this. So I did a f float. I call it my func, and I have something like a float. So then what this would mean is that whenever I say func, this entire thing, I can replace it with func, right? So what I can do is I can do something like a func fptr, and this will mean the same thing as before. So let's again run this just to make sure that everything is running fine. And as you can see, this is running perfectly fine. So what this would mean is that, you see, I say that func, and I automatically mean this because I'm using a type def. So this is kind of an something called aliasing. So instead of using this entire thing again and again, because you can imagine you can have many such function pointers, this becomes quite a cumbersome thing to type again. So you can do something called a type def, which is just aliasing. So calling something with something else. Just like a person can have two different names, and then this name can correspond to the then the two different names correspond to the same person. So that is exactly what type def does. It is kind of aliasing. What I'm saying is that wherever you see func in the code, replace the func in here with fptr. So then what this would mean, that whenever it sees func after this in the code, it copies everything from here to the position of position here, and replaces func with fptr. Okay, so this means the same thing as here. This means float. Right. So this is what exactly this means. Float f star p fptr. So this, as you can see, if you match by pattern, this func gets replaced by fptr. So similarly, you can have something like, instead of fptr, some other values. Then again, you click func, say abc, then equals to something like, say, cube. Then that gets assigned. Okay. So now let me now, okay. So I will also again pause once again and check the chat if there are any questions about this type def thing. I think this is also some thing which you was covered in some one of the lectures earlier about how type def works. So I thought that this is also a nice way to show you an application of type def. I'll come back once I hear the notification, but okay. How functions contain large code. So yes, so this is exactly how I'm showing you how you can use function pointers now. Then this saves you from writing the same code and again, and makes it extremely convenient. So this is exactly what I'm now going to show you, that how you can use function pointers. No, this is, as you know, that C is not object-oriented programming language like C++ or Python. So you do not have object-oriented features, but you'll see that how function pointers are useful. As I will demonstrate using something called the trapezoidal integration. So if you know, and if you can recall, there is something called trapezoidal integration, which we have covered yesterday and also in some of the previous lectures. It just you give a function and you want to integrate that function from some point A to some point B, and then you give the number of blocks in which you want to divide the function between A and B, and you want to carry out this numerical integration. So I'm just creating something like a float, right? And I'll call it trap z. This is going to do the trapezoidal integration. And now what are the things that it would take in? So it will first take in something called func f. So this is now going to take in a function, and now this will going to take in a and b. So these are the left and right values in trapezoidal integration. So from where to where you want to integrate, and int n is now going to take in the number that you want to div like differentiate your space into. So you want to put your space into like 10 different slices. So this is like that. So then your size of your h is b minus a over n, and then you do the trapezoidal integration, which is you want to carry out f. So see the thing in here, that this func f. Now, what this means is that this trapezoidal integration will take in a function as an argument. So this is kind of quite interesting in here, that this trapezoidal then function you can use then pass any function you want. and that function will be used for integrating, right? So this is a powerful concept. And then say, imagine you want to integrate x square from, say, some value to some value, and then you want to integrate x cube, and say then you want to integrate sine x. For all the different functions, you do not have to write a new trapezoidal integration function. All you have to do is you have to just pass the function that you want in here by using a function pointer, and this will be very useful. For example, this is one such function, so we'll create other functions as well. Say we'll create something called float linear, right? And we just return x in here. So we'll have linear, then we will have square, and then say, let's say we have float cube. So we return x cube, and then last one where we have something like a float, not this, but float of sine, right? And where we return like, okay, so let's call trig because it's a trigonometric function, and what we return is sine x. Okay. And now, since now we are using something called something like sine, we would need the math library. So let me also include that as well. So hash include math.h. So this just includes the math library. This allows me to use sine, basically. And here I have x squared, x cube, and these are the different functions, right? So now it is very simple right now to use this function. So let me get rid of this, and let me get rid of all the print statements. So what I can do now is I can do a printf, and I can do something like this. So trap z of linear from 0 to 1 with 100 data points is this, right? So let's see, trap z, let's not have this. So I want to do something like, let's have 1,000. So what I'm doing now here, right now here, is I'm calling trap z. So this is this function which I'm calling, and I'm passing it something called linear, right? So whenever I pass a function, now what I'm doing is that I'm passing a pointer to linear. So if you pass a function, what this does, it passes the pointer to linear. And you see that the linear, what kind of function it is, it is a function whose argument takes one argument, which is float, and returns one argument, which is float, and which is exactly the time kind of function pointer, which this is thing, which is, you see that this takes in an argument float and returns an argument float. So it's a func type. So the same type, and I do this. Similarly, right now if I go till the end of it, I'll just copy this, and now I can use it for different other calls, right? So now say I can have something like a square, just like I was having it before. I have a square where I just pass call square square. I have something like a cube, right? And I call cube. And then I can also have the trigonometric function, right? So I can have something like a trig. And here I'll just call trig. And you know that the integral of sine x is minus cos x. So if I integrate it from 0 to pi by 2, I'm going to get 1. So you know the value actually. So like let's define the value of pi then, right? So this is like the default value for pi. So instead of from 0 to 1, now I'm just going to integrate it from 0 to pi by 2, right? So I'm just going to integrate it from 0 to pi by 2, and I'm adding 1,000 points. So now once this is done, as you can see, this is very convenient right now because I'm now using function pointer. So I can directly pass a function, and that function is going to get evaluated in here. So when I'm using trap z with linear, this f is then linear. When I'm using trap z with square, then f is then square. So this is quite general. So you can write a function which is general, so you do not have to write it again and again, and you can then use a function pointer. So now let's run this. Yes, and now you can see, as you know that x, if you integrate x from x, it gives you 1 by 2 x square, and if you integrate from 0 to 1, you should get a 0.5. So you see, we exactly get the value of 0.5. Similarly, if you integrate x square, you get a 1 by 3 x cube, and if you integrate it from 0 to 1, it gives you 1/3. And then if you integrate x cube, you get 1/4 x to the power of 4. And if when you integrate it from 0 to 1, you get a 0.25. And similarly, when you integrate sine x from not 0 to 1, this is my bad in here. This is actually from 0 to pi by 2. So this is a printing mistake, as I say. I have some mistake in printing. So then you get 1. Fair enough. So I think this is quite clear to you right now, that why you would need a function pointer, and how is it convenient when you write a large code, and why it is useful to have a function pointer, so that you do not have to write the same code again and again. So is that clear to you, like how to use a function pointer and why you would need it? Okay, great. Okay, so once just like we have used function pointers for passing it, you can also have something called Lagrange interpolation, which we have dealt with yesterday. And now what we are going to do is, again, we will use function pointers for Lagrange interpolation, and we will use the data which we have already had. So we had the XY data. So we will read that data in and now try to interpolate it. So now the idea here is that, let's open Paint for you. So we had this data of X and Y, which is T and V. So now what we are going to do is you have read this data, use this data to make an interpolation, and we will use function pointers for interpolation as well. So that will be Lagrange interpolation. So that will then this is going to give you something like a function f as a function of x, or in other words, for this specific case, you will have v as a function of t. So after interpolation for any t, you will have this, and then we will be using this interpolation to use called trap z. So we'll we'll be able to integrate v as a function of t dt, and what this would give you is that it will give you the distance covered. So this is nothing but the distance covered. So imagine that you are doing this experiment. So the idea here is that you first create a file from your experiment, which gives you velocity as a function of time. You use this information to create an interpolation routine, which can give you velocity at any time in between as well. And then you use this interpolation routine to create a trap z function, which does a trapezoidal integration of your data points. And after integration, what you get is the distance that your thing has traveled. So this is kind of the rough idea of how this project what we were building. So we're now going to the last part of it, where we are doing the uh, kind of the Lagrange interpolation, and then we will be combining all these things which we have learned together separately to apply to this specific toy project, right? So let's then open one more file uh, in here, or yeah, and let's call it. Let's first do something like hello world in C. So again, we are starting with the hello world code. And now let's save this and call interpolator.c. Okay, so now what we are going to do is we create things like, so we don't know what the value of n will be, right? And we have something like an x data, y data. So now this is going to use it. Oops, sorry. And now we are going to have some variables which has this x data, y data set up, which we will read from file. For now, we will not have anything like that. We just first create the Lagrange interpolator thing. So we give float Lagrange, right? And we will have something like float x, right? So this is how a Lagrange interpolator would work. So you start with a sum, and you just give some value of x. You go to I, and this is what we have already covered before yesterday. So I'm not going into the details of the implementation of Lagrange interpolator, but I'm just telling you that this is how a Lagrange interpolator would work. Okay. And now let's also create a type def, which is going to be a float function. So yeah, okay, so now this is again, you already know what this is, that this creates a func, which is a pointer to float, right? And now let's create that as well. So I call this as func interp 1D. So this does 1D interpolation, and this just takes in you know, uh, float star x float star y. So this just takes you, oops, so sorry, things are have hanged a little bit for me. Anyways, so this takes you these arguments, and now this gives you, goes in here and then returns a Lagrange interpolator, right? So now whatever you pass in here as x and whatever you pass in y, that gets defined as x data and y data, and then n is defined as n. So these values are then get assigned, and then it returns the Lagrange interpolator. So it returns the interpolator that you have. And this function is basically the one which you will be using for going through the data and going through all the points, right? So this is returning it. So as I was saying previously, what we were using is using a function as an argument in the code. Now we are returning a function. So then now this is a function which returns a function pointer. Previously, we had a function which is like a integration function which takes in a function as an argument. Now this is a function interp1d which returns the function as an argument, right? So this is exactly what this will do. Okay, so now we are going in here. We already know the code for the like reading from file. So let's go to that in here, and let's check that code. So we are just going. I'm just going to copy this code because I'm already explained this to you what this does. It just reads the data, right? So I'm just going to copy this in here and go to my interpolator thing and paste it. I do not need these print statements because this is not anything which I'm printing, and all I need is these scans. So now what I'm doing in here main is I'm scanning this. I'm scanning all of these, and I'm just setting the X data and Y data. And once I have done that, all I'm doing is in here, let me do a for loop. It's better to use a for loop. Sorry, instead of doing this for sorry. Okay. So now what this does is it takes in this value x and I and assigns it to x data I and assigns this to y data I, and it goes from, this is n lines. So how many lines do you have? And then this is exactly what is n is nothing but n lines. So n gets assigned the value of n lines. So that's what you have. And then all the values of x data and y data are assigned to xi, yi, right? And here I read in the data files, and this is not x data, but I call it x points or x observation. So this is from like this is the experiment. So x observation and y observation. So these are the observations that we are doing, and we are having n lines in here. And once I read that, this scanf is now reading this x obs, and here I'm reading y obs, y obs. Okay, so now this is just the close of x obs, y obs. And we also need to close free the x data and y data as well. Actually, here we perhaps don't need this as well because we can use the same pointers. So I think the best way to do this is just call x data as x, yes, and similarly y. Data as y. Okay, and now I'm returning Lagrange because like I'm using the same thing. So for loop, I don't need a for loop to create a new variable. All I need is just to pass the same pointer. Okay, and there here malloc is just doing this xobs, and okay. So now I need to find the interpolator, right? So I call it in. So now I have a function which I call func f. So this is in top 1D. I pass x obs, y obs, and n lines. So I am passing this. So now what I'm doing is I'm creating this function. So this f is nothing but my interpolation function, which uses this Lagrange interpolator. And so now I can call it at any time I want, right? So now let's call this at any point of time and like some different values, and then we will know that if this function is working fine or not, right? So let's have something like a float x query. So we just want to find out where this is. X underscore query is this, and let's call x query plus equals 0.2 or 0.8, right? So then what we'll have is first we start with 0 and then 0.8, then 1.6, or rather have 0.5. So we'll have 0.5, then something like this. And then we are going to call f, right? So xy. So now what we are going to do in here is we have f, which is which we are calling at x, and which is equals to this f of x, right? So percentage point 2f equals to percentage point 2f, right? So now this is nothing but x query. So this is where I'm calling the function, right? And after this, I will do something like an f of x query, right? So f of x is this. And as you see, as you already know that if you recall the data thing that we have, if you look at data.txt, this is nothing but squaring it. So all we have are numbers between 0 to 5, 0, 1, 2, 3, 4, and the squares of this. And now I'm using the interpolation. And if my interpolator is fine, then at 0.5, I must get square of 0.5. And at 1.5, I must get square of 1.5. So any value in between will be interpolated using these points, which is also just squaring the numbers, right? So keep that in mind. Let's run this and let's see how this function is behaving. Okay, so you see this code has run. And so what this has done is it has first read the files. And after reading the files, did a Lagrange interpolation based on the numbers that it has read. And then use a Lagrange interpolator to square at the values where the, like, since the values which we have put in was actually a square of the values of x. So the Lagrange interpolator also then uses for squaring at the values where the function was not defined. So it is kind of interpolating in between the data points. So you see at 0.5, it gave you 0.25. Then at 1.5, it gave you 2.25. And then at 2.5, it's 6.25. So the values were for which the function was not defined. But since we are using this Lagrange interpolator, it is able to interpolate it. So this is kind of the idea. So is that clear to you, like how this function is working? And we are using this now kind of a function pointer to refer to that interpolation after we are creating the data. Yes, I understand this is kind of becoming a large code because we are discussing every sections of it one at a time, and then we are putting everything together so that it can be a little bit intimidating. But the thing is, what we are doing in here is first we are using a Lagrange interpolator. Uh, uh, and you don't need to worry about the details of how Lagrange interpolation is done because uh, that has already been covered in the last few lectures, and I'm not going to cover the details. But imagine that what this does is if you when you just you give it some value of x, it gives you what would be from some value for which the data is not available. So in between the data points, you can think of it. So this is what the interpolation does. So we have used, as I was covering at first, the file IO. So now what we are doing is we are reading in the data, which was in data.txt in this first part in main. Once we have read in the data, we are creating this x obs and y obs into which we are filling in the data which we are reading from file. And once we are reading from file, this is the call in line 52 we are calling interp1d. And what this interp1d is doing is using x obs and y obs with the number of lines to create a new function, which is the interpolating function, which is f. So this is the function, which is f. So now what this would do is that to this function, if you pass any particular value of x, which is actually not present in the data points, it will give you an approximation of what that value is, depending upon what are the data points in here. So if your data.txt had some other values, then obviously the values of f that you would get is different. So this is the idea that first we read in the file. After reading in the file, we are using that data points which we are reading in to an interpolator function, which is using Lagrange interpolator to give you a function which can give you values for any data points, for any points which is in between the data points for which the data is not there, right? And this is an example where we are trying to see if this is working or not. Okay. So I hope this is clear, because now what we are going to do, the final thing is that we will be using the what's that called? That trapezoidal integration, which we have covered just a while ago, to now integrate the data point from beginning till the end. And this is going to then be very useful in finding out the uh, distance covered, because it is velocity times dt, right? So for that, let's me go here, and then I'll just just kind of copy this function, which is trap z, and go back to my interpolator thing and paste it in here just before main, right? So now what this would do is, as you know, and I will not call this n, but I will call it n zones, just because there is already some value of n which was defined. So then I will also call this as n zones, n zones. And I think I have covered all the n zones in here. Okay, so as you knew that this what trapz was doing is I'm passing a function, and this function was what was used to integrate. So now the idea here is that this function, which I will be passing to trapz, will be the result of an interpolation. So that will be the interpolated function. The function returned by the interpolator is what we will be passing for integrating it. Okay, so now what we are doing is let's call float, right? And sorry, after this, I will call something like a float because this is a floating point thing, and I'll have to define a and b. So this is the beginning and end of the integration. So my a and b will be nothing but x obs 0, and then my b will be x obs n lines minus 1. So this is the last value. So this is kind of the integration where I want to do from the beginning till the end. So will give you the distance that the car is traveling, for example. And then I will do something like call something like distance, which is nothing but trap z of f. This f is nothing but what is given out by the interpolator. So this is the function which I'm passing. I want to pass it from a to b, and I want to do it for 1,000 steps. So this A to B is nothing but, if you remember, it starts from 0 and ends at 5. If I remember correctly, it starts from 0 and ends at 5. Right? So what we are doing in here is, and your function is x squared for this specific case. So you must get something like a 1/3 x cubed. So you should get a 1/3 times 5 cube as the final answer to this specific case. But in a more general example in real world, this can be anything, right? And now we'll have a printf statement where we are just printing. Okay. I'm just aligning the thing, which is not something necessary, but just for the sake of the code to look good. And now you just give distance is this, and let's now see the output of this code. And you can see this is distance is 41.67. And if you give something like, let me check, 5 cube, and you divide it by 3, you indeed get something like 41.67. So this is kind of the demonstration of how this would work, that you have started with an interpolation, and then you have used the interpolated function to run it on a trapezoidal integration, and have integrated it, and this gives you the distance that has been troubled. Okay, so this is kind of the idea. And now this is we are at the now end of it, and I am going to copy and paste this code for sure. So no doubt about that. So I will then copy the first part of the code where this is the thing where I'm creating the data. So I'll just copy this part first in the chat. Uh, Actually, what I'll do is I'll put as an attachment of both this code uh, downloads. I think what I have is here NPTEL. So what are the two things? I think demo and interpolator. These are the two things. Let me check. I'm sorry for the names, which are a bit confusing. I guess demo and interpolator are the two things that we had. And obviously data.txt, which is used. But this data is again created on its own, but I'm just uploading the 3 files. So these are the 3 files which you have. And what I will do after this is one thing which I can do is I will put this up in my GitHub repository and also share the link where I'll just put in some of the comments in the code for you to have this better written. To let me open GitHub and share with you the link to this. And then I will, the code is not there right now on GitHub, but I'll then put the code there on GitHub as well. Just a minute, let me just. For now, what I'm doing is I'm just creating the repository where I'll later on after the class, I'll put the code so that any of you can download the code from there as well. There I'll put in properly the comments and everything, and also put it in, and nicely arrange it so that it's easy for you to follow. Okay, so let me create a repository. So this is, I'm pasting it. So this is the link to the repository where you'll get the code. I'll upload it after the end of this class in 1 or 2 days with properly linking it so that you can get it in a way which is properly documented. But let me go to this, go back to the code where I was. Right? So just to summarize what we have done till now in here is that initially this is the Lagrange interpolator, which does the Lagrange interpolation for any value of x that you pass. This is the interp 1D where you associate all the x and y values. So these are the data points that you put in, and this returns the Lagrange interpolator. So what this would do is this will initialize your variable. So this initializes your data points, how many lines you have in the data point, and passes the Lagrange interpolator. So that later on when you use that, you'll use the interpolation function. And what this trap z would do is that if you pass any function to that trap z using this function pointer, it integrates from A to B with n number of zones. And the larger this number of zones, the more accurate will be your integration. So now we are going into the main code. Here in the first part, we are reading in the text file. This is the data place where this txt file has all as your observation data, right? So for this specific case, we have an observation data where the with time, the velocity of the car increases as square of time. And this is just a like a toy demo data, but you can have anything. We are using this because for this, the integral is analytically available, so we can compare whether the code is working fine or not. And then we can use it for any data we want. So now we are reading in the number of files in the code line, like in the text file. And depending on the number of lines we have, we are creating X OBS and Y OBS. These are the X and Y data points. These are arrays which we are creating. And in that arrays, we are reading in that values. Here in these lines, we are reading in the values from the file. Once we have read in the values, we are calling interp 1D. What this does is this initializes the interpolation function and returns that function as f. So this returns the Lagrange interpolated function in here as that f thing. And once we have the Lagrange interpolated function in here, we'll be using the Lagrange interpolated function in trap z. So what we are doing is we are integrating from the beginning of the time to the end of it. So that would mean at x obs. So this is your x point, which is time in this specific case. 0 is the beginning, and x n line minus 1 is the end of it. And then distance is where we are doing integration. For integration, we are calling trap z. And to this, we are passing f. Remember that f is the function which was obtained by using the Lagrange interpolation for the observed variables. So we are passing that same f and integrating it from A to B. So from the beginning of the time to the end of the time, and number of zones is 1,000. And here now we are now taking in and finding out the distance, which is the value of trapezoidal integration. And after we have done all of these, we are closing the file, which we have used for reading in the data. And then we are freeing the observable points. So x obs and y obs are exactly the ones which we are now freeing it. And then we have also printed out the distance which we have traveled. So this is basically the entire code which we have done. And for using this, we have exploited the different concepts which I was covering entirely through this through the session today. First, about file I/O. We have used file I/O for both the generating the data file and then in here reading the data file. We have used function pointers like the ones which we are used in here for integrating and also for interpolating. And we have used a type def as an alias to function pointers so that the use of function pointers is less cumbersome. So this is the entire summary of what we have done today. And this is perhaps quite a bit of a uphill challenge for you. So please take your time. This video will be uploaded on YouTube. You can pause it, you can play it slowly, or you can go through different parts of it if you wish. And most of it won't be asked in the exam questions or anything for you, but this will be more sort of preparing you for real life problems which you will encounter. And if you're interested in C programming language, this prepares you for that. So I hope that this session was useful to you and you were able to learn something which were out of what was is usually covered in the course. And I wish you all the best for your coming exams and also all the best for using C in your different programming endeavors in future. And I thank you for your time. And this is now the time, then I will end today's session. So I'll just also stop sharing the screen And if you have any questions, feel free to ask right now, and any doubts as well. And as I promised, I will also put the code up on GitHub where you will be able to access it for infinite amount of time for the foreseeable future. And I will also properly annotate you so that it is easy for you to understand. So on that note, I thank you all. I thank you all for your time and thank you for listening to me. And I hope you will now feel comfortable enough and confident enough to you see in different kinds of works that you will be doing in future. And yeah, I'll wait for just a few minutes for others to take questions. And yes, you can post other questions as well. Um, in one way to do that is you just pull issues in the GitHub repo. If you pull issues in GitHub repo with your questions, I would be happy to answer that. So feel free to pull issues in GitHub repo for now, and I can answer the questions there. Okay. So I thank you all. Thank you all for your time and thank you for listening to me. Thanks once again. And then I'm going to end my session in here. And